Hello everyone, myself Abhishek Paul. Currently, I am studying BTech, second BTech, first semester in the stream of Computer Science and Engineering at Srinivasa Ramanujan Institute of Technology. Today, I am going to discussing about explaining fixed versus floating point representation with animation for my DLCO assignment. Fixed versus floating point. Introdu- Introduction to number representation. Understanding number representation is crucial in digital logic and computer architecture. Fixed and floating point formats each serve unique purposes impacting precision and performance in various computing applications. Fixed point representation definition and use cases explained. And the first definition is fixed point representation involves using a set number of bits to express integer and fractional parts, making it ideal for systems that require consistent precisions. And it is used in this format is commonly found in embedded systems where resources are limited and precision needs are fixed, ensuring reliable performance in critical applications. And visual representation is as visual representation of fixed point number typically shows a binary number split between integer and fractional segments, clarifying the fixed point of bits used. Floating point representation, as you can see, definition and circuit number and diagram with clean diagrams. Floating point number consists of a sign, exponent, and mantissa ending greater precision. You can see the diagram which consists of mantissa, exponent, sign in floating point representation. The animated illustration of number representation. Fixed point represents with a fixed bit allocation. Here we can see 001010 where it represents the parts, and also floating point number represents number using sign, exponent, and mantissa. It range is floating point offers wide range and flexibility, and fixed point precision is fixed point has limit range and limit precisions. The range and precisions compared fixed and floating point formats. Fixed point representation has a limited range due to its fixed decimal position, making it suitable for applications with consistent precision needs like embedded systems. And also floating point. Floating point representation offers a wide range of values with variable decimal positions, accommodating extensive number calculations which is essential in scientific and engineering applications. Representing 12.375 in fixed point binary. 12 fixed point number represented with a fixed number of bits, as it divides 12 into one part, 375 as one part. Floating point number represented with sign, exponent, and mantissa. Here we can observe comparison between a floating point and fixed point. 12,375 equal to 14,356, which it converts into exponent and sign mantissa form, and highlighting differences in precision and range. But these system programming done in done we can't able to see this process because it all requires, and these operations are done in computer. And the example of 12.375 in floating point. In floating point, we can observe three parts of division. First one is normalization, second one is exponent, and third one is mantissa. In normalization, adjusting the binary number for representation, which we can observe 01174 represents 5, and similarly we have numbers converted into this normalization form. And also second step is exponent form, and it shows decimal point shift, where the decimal point is to be shifted after 2 before 3. And also third step is mantissa, representing the significant digits of the number. This mantissa helps in perfect form of the number, where the decimal form is to be placed and exact number is to be appear. And the animation of decimal conversion, real time, fixed and floating point. This section demonstrates the conversion process from decimal to fixed point binary, illustrating how bits fill in real time alongside the normalization and exponent calculation for floating point representation. Here we can now as of now we discussed about the 12.375 in floating point and fixed point representation with animations. Here we can see slight differences between these two, and then the advantages and disadvantages of representation, understanding precision and formation and performance trade-offs. The fixed point has uh, predictable precisions but limited range, while floating point offers a wide range at the cost of potential rounding errors. Each format serves distinct applications in computing. As we can see here, the difference int equals to 2 of, we can see difference between here. And last conclusion, key takeaways. Understanding fixed and floating point representation is vital for efficient computing. The number of IEEE 754 standard enhances precision and consistency, aiding developers in choosing the right format for their applications. Thank you for watching. This is Abhishek Paul signing off.